Now we'll talk about a particular kind of problem that combines integer properties thinking with algebraic thinking about consecutive integers. So the word consecutive means in a row or one following the other. So the term consecutive integers could mean any number of integers in a row. Could be the numbers from 1 to 100 or just 1, 2, 3. Those are consecutive integers. In fact, a set of 3 or more consecutive integers could contain both positive and negative numbers if the set contains 0. So for example, the set of 3 numbers, -1, 0, 1, those are 3 consecutive integers, and one is positive, one is negative, and one is neither positive nor negative. Some basic facts. A set of n consecutive integers will always contain one number divisible by n. Now, why is that? Well, if you think about it, say the multiples of 17. Well, every 17 numbers, you get to another multiple of 17. The multiples of 17 have to be spaced 17 apart. And so if you think of the numbers as kind of wallpaper, every 17 spaces you go ahead, you're going to come to another multiple of 17. So if I just take a random swath of 17 numbers, somewhere in there, there's going to have to be a multiple of 17. So for example, here, I have 7 numbers. And so it's guaranteed that there's going to be one number divisible by 7 in this group. That is guaranteed, and that one is 21. If I go larger, it's not necessarily guaranteed. As it happens, there is a multiple of 8 here. There's not a multiple of 9 here. If we go lower than 7, we're guaranteed that we will have at least one. So if we go down to 6, we have one multiple of 6, 24. We got lucky. We actually got 2 multiples of 5. We didn't have to get 2 multiples of 5, but we got 2 multiples of 5, 20 and 25, and then as you go down smaller and smaller, you'll get more and more multiples. If n is odd, then the sum of a set of consecutive integers will always be divisible by the set. So let's take these same 7 integers, we add them up, they add up to 161, and 161 is divisible by 3. And in fact, notice that when we divide it by 3, we get the median of the set. The mean and median of the set is the middle of the set. And if there's an odd number in the set, the median will be a number in the set. This is something we'll talk about a little more when we get to statistics. In a set of 3 consecutive integers, you could have 2 evens and 1 odd, or 2 odds and 1 evens, depending on whether you start. In a set of 4 consecutive integers, you must have 2 evens and 2 odds. So in a set of 3, we start at 20, we have 2 evens and 1 odd, but if we start at 21, we get 2 odds and 1 even. Sets of 4, notice that we have to get 2 evens, 2 odds, and notice because it's a set of 4, at least one of them has to be divisible by 4. So in the first set, 20 is divisible by 4. In the second set, 24 is divisible by 4. Because it's a set of 4, at least one number has to be divisible by 4. Now here's where it really gets interesting, the algebraic representations of consecutive integers. It's relatively easy to recognize consecutive integers when you're given actual numbers. The test likes to give algebraic representations of consecutive integers. So what does this look like? Well, for example, all of these are sets. So n plus 1, n plus 2, n plus 3, that's a little more obvious that we're getting the numbers one after another. It can also be with subtraction or subtraction and addition, n minus 2, n minus 1, then n plus 1, then n plus 2, that's fine. N plus 15, n plus 16, n plus 17, it would be odd if that were the case, but notice those are still spaced one apart. And so as long as n is an integer, then all of these will be sets of consecutive integers. Here's a practice problem. Pause the video and then we'll talk about this. Okay. We're told that n is an integer greater than 50. So in other words, it's not going to be convenient or easy to plug in numbers for this. So we have to be a little more clever. Well, notice that this expression is an expression that can be factored. And so we can factor out the n and then rearrange the terms. Notice that n plus 1 is 1 more than n. N minus 1 is 1 less than n. N minus 2 is 1 less than that. So what we have here is 4 consecutive integers, a product of 4 consecutive integers. Well, what do we know about 4 consecutive integers? We know that 2 of the numbers are even, 2 of the numbers are odd, so there must be a multiple of 4 and then another even number. Well, if we multiply a multiple of 4 by an even number, we're going to get something divisible by 8. So it's definitely divisible by 8. We have a multiple of 4. We also have a multiple of 3. Well, anything divisible by 4 and divisible by 3 is going to be divisible by 12. But 18 we don't really know. You see, 18 is 2 times 3 times 3. Are we going to have 2 multiples of 3 in this set? Well, maybe or maybe not. You know, if we had 11, 12, 13, 14, that would just have 1 multiple of 3, 12. But if we had 12, 13, 14, 15, then we have 2. We could, by chance, have 2 multiples of 3, but we don't necessarily have to have 2 multiples of 3. And so we can't guarantee, because this is a must be true, we can't guarantee that it's divisible by 18. So we'll eliminate that, and the only ones that work are 1 and 2. Sometimes the test may also ask about consecutive multiples of a number. For example, 25, 30, 35, 40 are consecutive multiples of 5. 35, 42, 49 are consecutive multiples of 7. 48, 51, 54 are consecutive multiples of 3. 65, 78, 91, and 104 are consecutive multiples of 13. So you're not necessarily asked to recognize multiples from sets of numbers that are given, but you'll be asked about a set of consecutive multiples. So here's an example question. Pause the video and then we'll talk about this. So 135 is the lowest number in a set of 41 consecutive multiples of 5. What is the difference between the lowest and highest numbers in the set? So this is kind of a sequence in a way. We know the first number in the set is 135. The second number is the next multiple of 5, so it must be 135 plus 5. I'm just going to write it like that. The next number is going to be 135 plus 5 plus 5, or 135 plus 5 times 2. And then 135 plus 5 times 3. So we see a pattern developing here. So the nth term is going to be 135 plus 5 times n minus 1. Notice that the factor by which we're multiplying here is always 1 less than the number of the term. And so that's why the nth term is 135 times n minus times 5 minus 1. 5 times n minus 1. So the 41st term is going to be 135 plus 5 times 40. I'm just going to leave it like that. Well, the first term is 135. The 41st term is 135 plus 5 times 40, and we want the difference. What's the difference between the highest and the lowest? So we subtract and cancel out the 135, and the difference is just that product, 5 times 40. Well, 5 times 4 is 20. 5 times 40 is 200. And so we choose answer choice B. In summary, we talked about consecutive integers, some of the examples and the basic rules, and those are very handy number facts to keep in mind about consecutive integers. We talked about the algebraic representation of consecutive integers, recognizing the pattern, and then applying the basic rules from consecutive integers. And finally, we talked about consecutive multiples of a number.